Hello, ladies and general glands. Back to video 3 with still no video 1. Haha, yay. Today we are gonna solve the questions after what I solved in video 2, which was question 19. We're gonna solve question 20 to 24 today because those are the ones that involve trigonometry. I mentioned the two basic formulas here if we have to reference them again later in the video because it would be hard saying the entire formulas again and again, right? So question 20 is basically very simple. You know, cosec x is 1 upon sine x. That's elementary trigonometry. So the question, wait, I'm doing a voiceover by the way. The question says the limit is where x is approaching pi from like pi and there's a negative on the top of the pi, right? What does that mean? That means the x is approaching pi from the left hand side of the graph, like from the left of the pi, like pi is 3.14, so x would be like 3.13, then 3.139, then 3 point something like that, right? It just approaches pi from the left hand side of the graph, right? So basically for sine is defined over pi, right? Sine is, we know sine is defined over pi. Sine is essentially like if you approach pi from the left hand side or the right hand side, sine, the pi, this value of sine is same. The limit of x approaching pi from the left hand side and x approaching pi from the right hand side of sine x is the same. It's zero. Like sine is defined on zero, sine is defined on pi, right? But for cosec it's different because the cosec is 1 upon sine, right? 1 upon 0 is infinity, right? So sine before pi is positive and sine after pi is negative, right? So the negative and positive, the difference between negative and positive here, like I will show that when sine is approaching x from the left hand side, 1 upon sine pi is going to be positive infinity because sine pi is positive essentially as it is approaching 0. When you approach sine pi from the right hand side, from values bigger than pi, sine pi is negative, right? Sine pi is negative. So the value cosec pi approaches is going to be negative infinity. That is the essential reason why we call cosec pi undefined, because like from the left hand side it's reaching positive infinity, from the right hand side it's reaching negative infinity, right? So we cannot attribute one value to the limit, right? So we call it undefined because like it's approaching positive infinity and it's also approaching negative infinity, right? So it's undefined there. That is essentially what undefined means: a function that is not continuous, that is not like there is no defined value at a point. That is what undefined means. Sine pi is defined on pi, right? But we, the limit is for cosec pi, and you are approaching pi from the left hand side. So as you can see, cosec pi approaching pi from the left hand side, from the origin side, yeah, the pi there, the negative, uh, we approach pi from the left hand side, like I drew the arrow there, we are gonna approach positive infinity. If we are approaching from the left hand side, we would approach negative infinity. That has to do with the sign of sine pi, limit of sine pi, as you are approaching sine x, limit of sine x as x is approaching pi either from the left hand side or the right hand side. Because the question said sine pi is approaching from the left hand side, we know simply that cosec pi is going to be plus infinity. That is a pretty easy answer. So yeah. All right. So question number. Okay, I'm just typing it all out again. Writing it all out again. Yeah. So it was a pretty simple question. Not that hard. Not that hard at all. I think the remaining questions were pretty easy here in this exercise. You might be indulged. Actually, yeah, this was a good point. Like I kind of was indulged to do this in first because like in the last video I mentioned you need to introduce variables, right? When you have something like something involves trigonometric limits. So you might be indulged to do this, and you realize that sine pi is equal to 0 and sine pi plus x. This is the identity of sine. You can expand it by sine pi multiplied by sine x plus sine cos, I think it was sine pi multiplied by cos x cos 0 plus cos pi multiplied by sine x, right? So yeah, sine 0. So the value comes out to be minus sine 0. So you know that simply, pretty easy. So now you might think, okay, minus the negative goes up straight, right? And then you would be like, okay, so there's a zero underneath and there is pi above, right? X is approaching pi. So you would be like, what? Why is the answer coming negative infinity? That's so wrong. Why is that happening? Essentially, what we are doing is we are not accounting for the fact that pi is approaching from the negative, from the left hand side. We are just accounting the fact that x is approaching pi. We are not saying that x is approaching pi from the left hand side or anything like that. Right? We are just saying x is approaching pi. And I also because like I just put in zero here instead of like the difference, the it's called the delta. Instead of putting in the delta, the difference between the actual targeted x value and like our x value that we take it as an example, um I just took delta zero, right? So that's simply wrong. That is not how it works, right? Yeah, this assumes x is standing on pi. This assumes that x equals to pi, and sine x is defined for pi. Cosec x is not. Cosecant is not defined for pi, right? So yeah, this was one problem here, and there was another problem. I will mention the problem really quickly. Yeah, I'm gonna write a lot of shit now because like, haha, uh, I needed to drag the video for some reason. Yeah, I'm kind of realizing I shouldn't drag the videos that much. Also, yeah, the other problem was like oh my god, we associated a negative sign with sign zero, right? Sign zero is zero. We cannot associate a sign with the value zero. Zero does not have a sign. Zero cannot be negative. Zero cannot be positive. Zero does not have a sign. So there were these two problems there. Now, question 21. Question 21 is x representing pi from sine x upon 2. Okay, yeah, I think I wrote the question wrong here. Sine x is approaching pi and sine bracket x upon 2 plus sine x bracket close. Like the whole expression is inside the bracket, as I will correct here. Yeah, just like that. The whole expression is inside the first sign. Mm-hmm. Mm-hmm. Yeah. So this question essentially solves itself if you put in the limit value. It's like not that hard. It's pretty simple. Yeah, I'm just realizing right now that I spent a lot of time like fucking writing a lot of stuff, redundant stuff. Yeah, so question 22, limit x is approaching pi cos square bracket x minus tan x bracket close. Like this is a pretty simple question, but like I'm just writing a note here that if you can't solve it on the first go, you have to like put in the expansion for cosine, the cosine expansion formula. Everybody knows that. You just have to put the expansion formula and then solve using some other identities if the expression does not work if you put in the limit. But if you put in the limit here, the expression actually works. Yeah, I had a brain fart here. I remember I just wrote tan pi equals to infinity or something like that, if I remember correctly. Yeah, undefined. I wrote undefined, huh? Because again, it's approaching like I thought it was approaching positive infinity and then negative infinity, coming back from negative infinity, which like defines no value for tan pi. But then I remembered, oh wait, that's pi upon 2. Yeah, because I'm more used to the degrees notation for angles and not the radian notation for angles. Because like, I was taught that way from like since childhood. So yeah. Forgive me. How about that, huh? So it's actually -1, huh? Let me actually think about it. Is that right? Is that right? Yeah, okay, my bad. Tan pi is actually 0, so it would just be cos square pi, and cos pi is essentially just um cos pi is -1, -1 squared is +1. So the answer is +1 here because tan pi is 0. I'm gonna write that in the video. Yeah. Yeah. So like the positive cosine goes in one direction, the negative cosine goes in the opposite direction, right? So if you add pi to the theta, like the direction of the cosine actually just changes, just flips, and the magnitude remains same. That is why you have the negative value when you add with pi, when you add the angle with pi. All right, so cos 1 squared, I okay, so it has to be cos pi. Again, I'm telling you that it has to be cos pi, which is just minus 1. So the value is actually just 1. You might want to just like think about it if you want to. I'm gonna move to next question because like I just thought, okay, cos 1 would be just a large decimal figure which I'm not gonna spend time writing down. So question 23 is limit x is approaching 0, 8x upon 3 sine x minus x. Pretty simple question. Again, like you use the sine formula, sine x upon x equals 1 formula when x is approaching 0. Just use that formula, introduce x above and below. Simply putting in the limit value would just give you 0, 0.0. So yeah, you just apply the sine formula. Yeah. Why am I dragging the video so much? Oh my god, this is so weird and strange and wrong. Huh. Okay, so yeah, what I did was to like simplify the explanation was I said, okay, the limit property where the power does not matter, the limit just moves inside, and I just like expand the fraction to like separate the fraction into two different pieces. I did this. I just gave the whole fraction a power of -1, which just flips the fraction essentially. So you can just like separate the fraction into 3 sine x upon 8x minus x upon 8x. Uh, yeah, I was being redundant with the limits. Forgive me about that. I just don't know if like you guys can follow but I how I solve, because I skip all these steps. Like I'm not even joking. If I were solving it for myself, I would have just skipped all of these steps. I just moved from 3 sine x minus x upon 8x to like the answer. Honestly, that is how I would have solved it. I'm trying to show you the solving process that I have learned to do in my head, right? So yeah, 3 sine x upon x from the first limit expression just like forms a 1, and you have 3 upon 8 remaining. The x's cancel out in the second limit expression, and you just have 1 upon 8 remaining, and all of this is raised to the power -1. So you just get 4 upon 8 -1. So you just get 2 as your answer, right? 2 is your answer, because like this expression will be 1 upon 2, 1 upon 2 raised to the power -1, which is just essentially 2, right? Yeah, so we are going to move to question number 30. 24. Yay, 24. Yeah. 24 is limit x to cos 2x minus 1 upon sin x. Alright, so let's remember these formulas. I told you to introduce variables. Yeah. So, hmm, it's cos 2x. Yep, sure, sure, sure. Yeah, so whatever the h is, you need a h below to like form this expression. Whatever the h above is, you need the h below. Like you need the expression below to be the same as the h above. So you need a 2x below. And like when you do that, when you do the 2x, you automatically get an x above. Like on the top, you get, or you automatically get an x, and you can just like use the first formula, sine x upon x formula, uh, on the x upon sine x, right? So you get, yeah, it's like fairly simple now. Cos 2x minus 1 upon 2x multiplied by 2x upon sine x. So you just get 0 multiplied by 2, which is simply 0, right? Yeah, again, me being extra, so like wasting my time, honestly, simply. wasting all my time. The x and the sin x form. Yeah, this was done to make the thing, make the expression cleaner. It looked very ugly. The x and sin x just form a 1, so you get, as x is equal to 0, you get 2 multiplied by 1 multiplied by 0 simply. Multiplied 1 upon 1 multiplied by 0 upon 1, so you get 0. 0 is your answer. 0 is your answer. 0 is your answer. Yay. Yeah, okay. Goodbye. Video 4 coming soon. ASAP. Right as I finish this video. Yeah. I want to make video 4.